In this lesson, we're going to be solving exponential and logarithmic equations. An exponential equation is an equation in the form of y equals a times b raised to the cx power. A and c are real numbers. B has to be greater than 0, but not equal to 1. So here we have 3 to the x is equal to 75. Our first step here is going to be rewrite in log form. So you're always going to rewrite in log form when the variable is in the exponent. So when the variable is in the exponent, you're always going to do this step first, rewrite in log form. So we've got log base 3 of 75 is equal to x. And that's what allows you to get the exponent x out of the exponent when you have log form. So you've got a base, you've got an argument. You'll be able to get some number here by using your calculator and the change of base formula. So we've got the log. We can use log base 10 or we can use natural log. If you like log base 10, we'll do log base 10 of 75 divided by log base 10 of 3. That's equal to x. We put that into our calculator, and I'll give you a second to do that. Log of 75 divided by log of 3. And to the nearest tenth, you should get about 3.93. Okay, so we'll try another one. We've got 4 raised to the 3x power equals 15. Now we've got a variable in the exponent, so that variable is in the exponent. Therefore, our first step is to rewrite in log form. So we'll have log base 4 of 15 is equal to 3x. Now what we need to do for our second step is we need to solve for x. And sometimes that involves the change of base formula. So remember that this is just some number. It's going to be log of 15 divided by log of 4 is equal to 3x. Once I get this value, I'm going to divide both sides by 3. And we get x is approximately. Now I'm going to show you the purple part in my calculator. I'm going to actually put is equal to that purple part in my calculator, and then I'm going to divide by 3. So I'm going to put the purple part in the calculator. And remember, you can use the log button or you can use the natural log button. It was natural log or log of 15 divided by natural log or log of 4. And we get 1.953, that decimal, and we're going to divide that by 3. So it was 1.953-ish, and then we divide that by 3. Now I'm just going to write this down, 1.953-ish. And then you divide that by 3 and you get the answer, which is approximately 0.65. So that's approximately x. So we're not going to round until the very, very end. Notice how I took that entire value and I divided it by 3, and I didn't round until the very, very end. Okay, here's another problem where we have x in the exponent. So I think we're at the point where if you'd like to try this, you should know enough to try this. Go ahead and give it a shot, press pause, and then come back and check your work. So because the variable's in the exponent, we're going to write this as log base 7 of 350 is equal to x. And then log base 7 of 350 is the natural log of 350 divided by the natural log of 7. And when I put that into my calculator, I get approximately 3.01. Okay, if you didn't try the second one already, press pause. If you did, I'm going to go ahead and show you right now the answer. We should have log base e of 2 is equal to x. Log base e is the natural log of 2 is equal to x. And when we put the natural log of 2 into our calculator, we get about 0.69. X is approximately 0.69. Now, in these problems, we most definitely have a variable in the exponent. So I'm going to be rewriting these in log form, but right now it's a bit complicated. So I need to isolate just the base of 3 raised to the 2x minus 1 power. So I'm going to start by subtracting 8 from both sides. When I subtract 8 from both sides, I get negative, and then 3 raised to the 2x minus 1 power is equal to negative 7. Now this opposite is not attached to the exponent, which is a good thing because we don't want that base to be negative. So we're going to divide both sides by negative 1. And the negative divided by the negative cancels out, and we get 3 raised to the 2x minus 1 power is equal to positive 7. Now we can write in log form, log base 3 of 7 is equal to 2x minus 1. Now, before I rewrite the log base 3 of 7, I'm going to solve for x. So I'm going to solve for x algebraically. Because of the complication that we've got here, I'm going to add 1 to both sides. So I've got log base 3 of 7, which is just some decimal number. And then we're going to add 1 to it. And that's going to equal 2x. Then we're going to divide both sides by that 2. So I'm going to divide the entire side by 2. So I'm going to get x equals, now the exact answer is log base 3 of 7 plus 1 all over 2. But when I put that into my calculator, and I'm going to show you something else that's in your calculator. So now we're getting to the big stuff here. So I've got log base 3 log base 3 of 7, I believe is what it was. Log base 3 of 7. And then we added 1 and divided by 2. So I've got this fraction bar, and I want to put log base 3 of 7 in. So I'm going to show you something. You're going to hit the math button right here. So F4 for math. And then do you see the log AB? You're going to hit F2, and you're going to put in log base 3 of 7. And then outside that 7, we added 1, and then we took all of that numerator and divided by 2. And we press enter, and we get 1.386. 1.386. However, I believe that we've been rounding to the nearest hundredth, so I'm going to make the 38 a 39. 1.39. 1.39. So x is approximately 1.39. Okay, let's try that again. We've got 2 raised to the 4x power. I need to isolate this all by itself, so I'm going to subtract 17 from both sides. 2 raised to the 4x is equal to 51. We've got log base 2 of 51 is equal to 4x. We divide both sides by 4, and now practice using that button again. X is equal to log base 2 of 51. Whatever that value is, we're going to divide it by 4. So press pause, try and get that in your calculator. Okay, you should have gotten 1.42. 1.42. Okay, in the next video, we will be solving logarithmic equations. So we just solved exponential equations, and in the next video, we'll be solving logarithmic equations.